So in this video I am going to discuss this problem of group theory. This problem is very much relevant to various competitive exams. So the question says that prove that a group of order 15 is always cyclic. So you can see the solution which I have written here. I am explaining the solution. So to prove that the group of order 15 is cyclic, I have to prove that there is an element of order 15 uh, in that group G. So one thing is obvious that there are elements of order 3, 5, 15 in that group. So without loss of, let's say, let X and Y are two elements in G whose order is 3 and Y has order 5. Now let H1 is the subgroup generated by X and H2 is the subgroup generated by Y. Now our first target is we'll prove that H1 intersection H2 is basically identity element. To prove that let A belong to their intersection. So for that reason A cube equal to identity, and since A belong to H2, that's why A to the power 5 equal to identity. So after cancellation I will get A square equal to identity, and again by cancellation I will get A equal to identity. So in the intersection between H1 and H2 there is only identity element. Now the order of H1 H2 is equal to, there is a well-known formula for which which says that order of H1 H2 is equal to order of H times order of H2 divided by order of H1 intersection H2. So since order of H1 intersection H2 is identity, that means the order of H1 H2 is basically 15. So one can easily say that group G is basically H1 H2, because H1 H2 is a subgroup and it has order similar to the original group. That's why G and H2 are same. Now clearly that XY element which we have taken in the beginning, it belong to the H1 H2 which is equal to G. Now we will prove two things. One is we will prove that XY equal to YX, and second, when using that we will prove that order of XY equal to 15. So to prove the first thing, we'll use Silo theorem. You can see the statement of Silo theorem. So using Silo theorem, I'll show that n3, which is equal to 1 plus 3k divides 5. So one, using basic elementary number theory, we can say that n3 equal to 1. And similarly, n5 piece 5 Silo subgroup, which is 1 plus 5k divides 3, from which one can say that n5 equal to 1. So we also know that while known result, if n1, if the Silo subgroup is unique, that means it is normal. So you can easily say that H1 and H2 are normal in G. Now consider this element x, y, x inverse, y inverse which belong to the intersection. Why? Because you do normality, you can check this, because x, y, x inverse belong to H2 and x, y, x inverse, this thing belong to you be using normality, you can check this thing. So and since we know that only identity element belong to their intersection, that means that x, y, x inverse, y inverse equal to identity. That means xy equal to yx. Okay, these are one of the goal which we have proved. Now xy to the power 15 equal to x to the power 15 times y to the power 15. How I can write this? Because I can write this because of this result. Due to the commutativity of x and y, I can write like this, or else it is not always true. So which is equal to identity, because x to the power 3 equal to identity and y to the power 5 equal to identity. That's why it is identity. That means that order of xy is divisible of 15. Now one can easily check that implies order of xy equal to 1, 3, 5 and 15. but one can easily check that x these first three will not be true. So only possible case is order of xy is 15. So basically we got a element whose order is 15. That's why G is cyclic. Thank you.